All right, what's up, guys? Mr. Rushka here. Today, in these 4.2 notes, we're going to talk about solving systems of equations with three variables, okay? So before, right, we solved systems of equations where there were two equations and two unknowns, two variables. Now we're going to solve systems that have three variables and three unknowns, okay? So here's how we do that, okay? So starting with example one, actually, if you want to pause the video right now and maybe screenshot these steps right here, are actually pretty good. I like these steps, okay? So we'll try to follow this set of steps, okay? So maybe pause, screenshot, and we'll continue, okay? So let's start with problem number one, okay? So we're going to try to use elimination here. We want to try to use elimination, okay? So recall from the section where we did systems of two equations that, so let's take, for example, these two. Let's look, for example, at these two equations, right? Elimination meant we would try to add these two equations together in such a way that when we added them together, one of our variables would cancel out. And we'd be left with one equation and one unknown, okay? So we're going to do the same, do the same principle here. We just have to, do everything twice. So here, you'll see what I mean by that, okay? So let's focus in on these first two equations. So I'm going to put a red squiggly here, okay? All right, 2x minus 6y plus 9z equals -8, and 5x plus y plus 2z equals 10. Okay, so I want to add everything in these two equations together. Okay, I want to add everything in these two equations together such that when I do that, one of my variables is going to get canceled, okay? All right, so let's look at what we've got here. 2 and 5 for x, my coefficient for the x. My coefficients for y are -6 and 1. Coefficients for z are 9 and 2, okay? Well, I'm looking at the y variable here. I'm going to look at the y variable, okay? All right, I have -6 next to my first y, okay? If I add positive 6 to -6, I'm going to get 0, and this y variable is going to cancel out. So if I can just get there to be a 6 here, I can add these two equations together, and that'll cancel out my y. So let's do that, right? So to get a 6 here, I got to multiply both sides of this equation by 6. Okay, so I'm going to be left with, so 30x plus 6y plus 12z equals 60, okay? And then I have just this first equation here still, 2x minus 6y plus 9z equals -8, okay? So I still have that first equation, okay? And then when I add them together, I get 32x plus 0y, the y's cancel, plus 21z equals positive 52, okay? All right, so I have this red equation here, okay? All right, I'm going to leave that be for now, okay? So I've got to eliminate, what I've got to do now is I've got to look at this third equation here, and I've got to, so I'm going to erase all this. I've got to do the same thing with this pair of equations that I have right here, this blue, all right? I've got to do the same thing with this blue pair of equations I have, okay? So the way I'm going to do that, right, so let's see what one thing I got to do right here. All right, so now I'm going to do elimination on these two equations with the blue bracket next to them. What I've got to do is I have to eliminate that same variable. So I can't say like, oh, let me eliminate x or let me eliminate z. No, whichever variable I eliminated in my first step, so y has to be the variable that I eliminate in my second step. So I've got to eliminate y here, okay? So let's think about this. I want to think of, right, when I add these two equations together, I want my y's to cancel, okay? So I've got a positive 1y here and a positive 1y here, okay? When I add let's look at this top coefficient, positive 1. When I add -1 to positive 1, I get 0. That variable is going to cancel. So I need to somehow make this 1 here into a -1, okay? So what I'm going to do is multiply both sides of this equation by -1. So times, let me move this squiggly out of the way. So -1, okay? That's going to give me negative 3x minus y plus 8z equals positive 28, right? Let me check my work. Yep, that looks good, okay? And then I've still got this equation right here, okay? So let me move that down here. 5x plus y plus 2z equals 10, okay? Add these two together, okay? You get 2x, the y's cancel, plus 10z, so the y's cancel, equals 38, okay? Boom. All right, here's what's going on now. I'm going to combine these two. I'm going to take these two equations here now, right? And I'm going to make those two, I'm going to make these two into, now I've got two equations with two unknowns, okay? I have two equations with two unknowns. Look what I've got now, guys. I have a system of two equations. I have a system of two equations now, okay? So now, right, this is just like we did in the other lesson the other day, okay? This is from Algebra 1, okay? So we can solve this one, okay? So I'm actually going to use elimination to eliminate x now. So we're just going to do this part of the problem just as if it were a system of two equations problem, okay? So I'm going to do elimination because I notice when I multiply this 2 by negative 16, it gives me negative 32x. And negative 32x plus positive 32x will cancel out the x here, okay? So let's do that real quick. So multiply both sides of this equation by negative 16. Okay, that gives me negative 32x. All right, minus, what is that, 160z equals 38 times negative 16. Let me use my calculator for that real quick. 38 times negative 16 is negative 608. Okay, and then I've still got this equation from up here that I'm just going to pull down here. Okay, so we have 32x plus 21z equals 52. All right, so let me add these two equations together. These x's will cancel. Negative 60 plus 21 is negative 139z. And that equals negative 608 plus 52. So that equals negative 556, okay? Good stuff. Let's divide both sides by negative 139, get z by itself. All right, we get z equals 4. We get z equals 4 from this. So there we go. I got my first variable solved for, okay? There we go. And then what I can do is I can just take my z equals 4 and plug it back into one of my equations up here just like I did. So let's do this blue equation, okay? So we're going to have 2x plus 10 times 4, right? I plug in that z equals 4 right here, okay? I plugged in z equals 4 equals 38, okay? Now I've got 2x plus 40 equals 38. Subtract 40 from both sides. I have 2x equals negative 2. Divide both sides by 2. I've got x equals negative 1. Okay, there we go. Second variable solved for. Okay, so we have an x and a z. And then I go back to my original system, and I can just take any of these and plug in an x and my z and solve for y. So let's do it with this bottom one real quick, okay? So let's, I'll highlight this in green, okay? So I'm going to do 3 times my x. What's my x? It's negative 1. So 3 times negative 1 plus my y. What's my, not my y. I don't know y yet. Plus my y. Then minus 8 times my z. What's my z? It's 4 plus 8 or minus, what is that? Yeah, minus 8 times 4. That all equals negative 28. So just that original bottom equation. Okay, we get negative 3 plus y minus 32 equals negative 28. Combine like terms, we get y minus 35 equals, equals negative 28. And then we'll add 35 to both sides. Okay, and we get y equals positive 7. Boom. Done with this problem. Okay, we can check. We can plug in all of our variables here. So I'll make 3 variables I solve for. I can plug those in to my original system. I get 2 times -1 minus 6 times 7 plus 9 times 4. Right, that's going to give me, I'm just going to plug that whole thing into my calculator. 2 times I get 2 times -1, that's -2, minus 42 plus 36. Oh, just wrote 63 plus 36. That equals -8 here, which checks out with my original equation here. Okay, so that works with the first equation. Let's check with the second. Okay, so we get 5 times -1 plus my y is 7 plus 2 times 4. That equals -5 plus 7 plus 8, which equals positive 10, right? And that checks out with what I have over here, okay? Good job. And then let's plug in for this third equation, okay? So we have 3x, so 3 times -1 plus my y, which is 7, minus 8 times my z, which is 4, right? That equals -3 plus 7 minus 32. All right, and that is what, 28? Or -28. Good job, -28. And that checks out with what we have over here, okay? Good, so that's the first example in the book. So pause, rewind, slow down if you need to. Ask Mr. Miller for help, okay? Let's go on to number 2. Number 2, all right. Okay, well, I notice, how do I want to do this? I notice right off the bat that this -3 with this positive 3 cancels out right away. So I guess I'll just do that, yeah. So let's make these my red pair of equations, okay? So I have 4x plus y minus 3z equals 45, and 6x minus 4y plus 3z equals 41, okay? So I don't even have to multiply anything, right? I already have 2 variables that are going to cancel out, okay? So let me add 4x plus 10x is, 4x plus 6x is 10x. -4y plus positive 1y is -3y. And then these 2 are going to cancel out. So this gives me 45 plus 41, which is 86. 86, okay? So there we go. Now let's switch to blue and hone in on this second pair of equations. So now what I have to do is I specifically have to eliminate, since I eliminated z over here to begin with, that second step, I have to eliminate z as well. This is why I was debating, right? Because 3 and 11, there's not really anything I can multiply 3 by to get 11. I can do like a gross fraction. So let me think what I want to do. I don't want to do fractions, so what I'm going to do is I'm going to multiply this 3 by -11. No, I'm going to multiply this 3 by 11 to give me positive 33. I'm going to multiply this -11 by 3 to give me -33z, and then adding positive 33 and -33 together will cancel these out. Kind of a pain in the butt, but that was the price to pay for picking z as my elimination variable, okay? So let's do that. Let's move this squiggly a little bit out of the way, okay? So we have 11, multiply this by 11 on both sides, multiply this by 3 on both sides, okay? We get 11 times 6 is 66x minus 44y plus 33z equals 41 times 11. Be sure to always check your work a lot on these guys, because even if you know what you're doing here, there's a lot of room to make mistakes. There's a lot of opportunities to make dumb mistakes. So 3 times 2x is 6x, 3 times minus 7y is -21y, 3 times -11z is -33z. That equals 85 times 3, which is 255, okay? So let's add these 2 together. Right, I think I did that right. Just want to check my work here. Good, so we get 72x, -44 minus 21 that's minus 65y. That cancels, equals what's 451 plus 255? That's 706. All right. Good stuff. So I'll take my two equations. All right. Oh, no, don't want that little bar. I'll take my two equations here. Copy. Paste. Okay. I'll make a system out of them. Just going to make a system out of my two equations. These two equations here. So that's 72x minus 65y equals 706. And then now it's an Algebra 1 problem. I solve it just like my systems of two equations. All right? So let's see what I want to do here. Do I want to do elimination or substitution? Well, okay. Just going to have to pick what I want to do. All right, might have to bite the bullet here. Don't want to do this, but I think I might have to. I'm going to do the least common multiple. Least common multiple of 10 and 72. What's that? 360, okay? So I can multiply this 10 by 36. That gives me positive 360. I can multiply this 72 by 5. That'll give me, or negative 5. That'll give me negative 360, okay? And I can add these two together, cancel out my x's, okay? So let's do that. Let's multiply 10. Let's multiply by 36 on both sides here. So my numbers are getting big, but the reasoning's still the same, okay? All right, and then down here, I'll multiply by negative 5 on both sides. Okay, so this first equation, I get 360x minus 108y equals 86 times 36, so 3,096. Then I get negative 5 times 72, which is negative 360x. Negative 5 times negative 65. That gives me plus 325y. That equals 706 times negative 5, which is negative 3,530, okay? So be sure to check your work a lot on these guys. A lot of room to make mistakes, okay? Let's add these two equations together. I get... Oh, whoops. I get 217y equals, it's 3,096 minus 3,530 equals negative 434. Okay. Divide both sides by 217. Gives me y equals negative 2. There you go. All those big numbers reduced down to y equals negative 2. Okay, so there's my first one, my first variable. So I'm going to go ahead and come up here to this red equation, plug negative 2 into this original red equation for y, okay? So I get 10x minus 3 times negative 2 equals 86, or 10x plus 6 equals 86. 10x equals 80, divide by 10, divide by 10, I get x equals 8. So there we go. Right, and then I compare, so then I can plug this y and this x, and let's do this top equation and solve for z, okay? So I have 4 times my x, which is 8, so 4 times 8, plus my y, which is negative 2, so it's just going to be minus 2. And then minus my 3z, that's going to equal 45. Okay, it's going to equal 45. All right, so we got our y coordinate, we got our x variable, okay? So we can just plug both of those, take both of these, all right? Plug them into this top equation for x and for y, so that's what I did right here. All right, then I just need to simplify. So we get 32 minus 2 minus 3. Oh, sorry. 32 minus 2 minus 3z equals 45. Combine my two like terms here. I get 30 minus 3z equals 45. Subtract 30 from both sides. And I get negative 3z equals, what's that, 15. And then divide by negative 3 on both sides. That gives me z equals negative 5, okay? So there you have it. There you have it, okay? All three of my variables solved for, okay? So easy money, all right? Easy money. Just that extra step at the beginning, getting it down to a system of two equations, and then we can solve for those two variables, plug them back into any of these three originals, and then we can get our z from there, okay? Let's go to number 3. Number 3, okay? So I'm looking at this, okay? Remember, first step, we're looking at the coefficients of my x variables, my y variables, and my z variables, and we're looking for coefficients that are easy to cancel out with each other. So first thing I see right here, I have a negative 1z here. That's going to be easy to cancel with my 8 since I just have to multiply. If I multiply this by 8, the negative 8 plus 8, that cancels. If I multiply this by 4, then negative 4 plus 4 cancels as well. So I'm going to pick this one, and I'm going to cancel out my z variable first, okay? So let me go ahead and start with these, label those red, okay? And then I'm going to multiply, right? I got to get this to be negative 8, so it'll cancel with the positive 8 here. So I'm going to multiply both sides of this equation by 8. All right, so I'll have, let me just copy that first one down. And then I'll have 8 times 9, that's 72x minus 32y minus 8z equals negative 480. Okay, let me add these two together. Okay, so 5 plus 72 is 77x. Negative 3 plus negative 32 is negative 35y. And then 8 plus negative 8 is 0. So we get the negative 59 plus negative 480. Let me get my calculator out real quick. There we go. Negative 59 plus negative 480. That's negative 539, okay? There we go. So that's going to be our first equation, right, for x and y. Now we're going to go to, okay, remember, so now I'm going to go back here. I'm going to use this bottom equation that I didn't use in the first step. So the second step, I have to use the bottom equation. And then in my second step, I still have to cancel out z. I have to cancel out z with that other equation I didn't use, okay? So right, so I need this minus, now I need my negative z to be a negative 4z, so it'll cancel out with the positive 4. So let me go ahead and multiply both sides of this equation by positive 4. All right, so we'll get 36x minus 16y minus 4z equals negative 360, okay? All right, and then I can just add these two equations together. 5x plus 36x is 41x, plus positive 2y minus 16y is negative 14y minus 14y. These cancel, then negative 47 plus negative 36 equals negative 83, okay? Good stuff. Okay, now if I just copy this over here real quick. Right now, I have a nice, let me get rid of that line. I have a nice system of equations right here, okay? Let me just get rid of this line real quick. All right, so now I can just treat these two equations as their own little system of two equations. This will get me x and y, okay? So 77x and 35y. Let's think about this. So this is kind of a pain in the butt. All right, so I'm going to try to cancel these out. Here's what I'm going to do. I'm going to multiply the top by 2. I'm going to multiply this top equation by 2. And I'm going to multiply this bottom equation by negative 5. Well, that'll give me positive 70. That'll give me negative 70y here, plus positive 70y here. That'll cancel out the y. I can solve for x, okay? So let me do that real quick. So multiply by 2 on both sides in the top. Here we get, what's 77 times 2? We get 154x minus 70y equals negative 539 times 2. That gives me negative 1,078. Okay, and then this bottom equation right here, I'm going to multiply by, what was I saying, negative 5 on both sides, so negative 5 times negative 5. Okay, we get negative 5 times 41 is negative 205x. Negative 5 times negative 14 is positive 70y. That equals negative 83 times negative 5. All right, then we can add these together. The y's cancel out. We'll get 154 plus negative 205. Get negative 51x equals, oh gosh, I hate it. Yeah, you guys are good. You guys are fine. All right, so negative 51x equals, oh gosh, equals negative 1078 plus 415. It's negative 663 divided by negative 51 on both sides, divided by negative 51. We get x equals 13. Oh, woohoo. Nice. There we go. So we have our first variable, our x, okay. I'm just going to go ahead and plug this into my original blue equation right here to get y. So I'll have 41. So to get y, I'll have 41 times 13 minus 14y equals 415. Or, no, equals negative 83. Sorry, this equals negative 83.
Yeah.
All right, so I just plugged in 13 for x here, okay? And 41 times 13. It's going to be 553 minus 14y equals negative 83. And subtract 553 from both sides. Okay, negative 83 minus 553 equals negative 636 divided by negative 14 on both sides. Be careful, guys. There's a lot of room to make mistakes here, okay? We're working with some big numbers, so check your work. Yeah, I think I might have made a mistake right here, actually. So let me see what I did. I got 13. I got 13 for x. Plugged it in here.
I think she told me I was on full clear with the day.
Yeah, this gave me 318 over 7, which I don't think is the answer for y. What do you think mistakes I might have made? So we got 41 times 13, I got 500. Oh, here's the mistake I made. 41 times 13, that's not 553. 41 times 13 is 533. So this should be a 533, okay? So let me actually go back and delete all this. Sorry, guys. Again, okay, I mean, I'm making a lot of mistakes, okay? So be careful, okay? So this is 533. Tons of room to make mistakes here, guys, so be careful. Negative 14y equals negative 83 minus 533. That's negative 616.
Hi, Dr. Burkhardt. I don't think you remember me. You were showing the.
We'll divide by negative 14 on both sides. All right, we'll have y equals 44. Thank you, guys. You guys are the bomb, okay? Thank you for bearing with me. All right, so we got x equals 13, y equals 44. All right. So we got those first two variables, and then we can just plug these two guys in. You guys are fine. You guys are fine. And then I can just plug my x and y into this top equation, or the middle, or the bottom, doesn't matter. And we can use that to solve for z, okay? Sorry again. All right, so I'll use my two variables here, my x and y. I'll plug them into my top equation, so that's going to give me 5 times 13. Minus 3 times my y. What's my y? It is 44. Plus 8z equals negative 59. Okay, let me just erase this line right here. Gosh dang it. Sorry, guys. This is a challenge. Okay, so I'm just going to erase all this. Okay. So we get, what's 5 times 13? That's 75. Minus 3 times 44. What's 3 times 44? 3 times 44, that's 132. Plus 8z equals negative 59. Okay, 75 minus 132, that's negative 57. Plus 8z equals negative 59. Add 57 to both sides. We get 8z equals negative 2. Divide by 8, divide by 8. We get z equals negative 1/4. Fun. Lots of fun. So these are our 3 variables. That's our z, there's our x, there's our y. Okay, and guys, be careful to make mistakes. If you're doing this math and you see I've made a mistake, I apologize. There's just like a million different opportunities to make a mistake when you're doing this. It's not too complicated of a process, but there's just a lot of room for mistakes. So let's move on to number 4. Okay, so I'm going to move this out of the way. Oh, gosh. All right, so number 4. Let's look. look at this x. I got this 1x here. If I multiply that by 2, I have a positive 2 that cancels with my negative 2 up there. If I multiply this by negative 4, I have a negative 4x that cancels with my 4x right here, okay? So let me go ahead and do that one, okay? So let's do these 2 equations first, okay? If I multiply both sides of this by 2, positive 2, I get, so I'm just going to copy that top equation first. I get 2x, positive 2x, plus positive 4y, minus 6z equals 8. Okay. All right. Notice when I add these together, I just get 0 equals 0. Uh-oh. What's going on there? So these first 2, what that means is, so if you notice, these first 2 equations right here, the red that I have bracketed in red, okay? So notice that they're just multiples of each other. So if I multiply both sides of this by negative 2, I get the same equation here. So these 2 equations here have an infinite number of solutions together, okay? So I know they have an infinite number of solutions right here. Infinite number to these top 2 equations, okay? Let me look at this bottom here. So if I bracket these in blue, right? Multiply both sides of this by negative 4. I get negative 4x minus 8y plus 12z equals negative 16. Notice that when I do that, these 2 equations cancel all the way too. We just get 0 equals 0. All right, so this means, since we just got 0 equals 0, everything canceled with each other. This means we've got infinitely many solutions. All right, these are all the same equation, just different. They're just different scalar multiples of each other. Okay, infinitely many solutions. Okay, let's go on to number 5. Number 5. Uh-oh, we're missing some stuff. What does that mean? Well, it doesn't really mean much. Okay, don't worry about it too much, guys. We just keep doing this the same way. We just technically have like a 0x plus y and then like a plus 0z here. So nothing too technical. Okay, we just go about daily life. We just go about our business the same way. So I'm looking at, I've got a 1y here, right? That's going to be convenient because if I multiply by negative 2 here, cancels with the top. If I multiply by positive 2, cancels with the bottom. Okay, so I'm going to pick these. Let's do these first 2 equations. Okay, let me multiply. What do I need? Negative 2. My negative 2 on both sides. All right, we get. I'm just going to copy that first one down. 2x plus 2y minus 3z equals 1, and then I get 0x minus 2y minus 4z equals positive 28. Okay, I add those 2 equations together. I get 2x, these cancel, minus 7z equals 29. Okay, and then, so that's going to be one of my equations. Let me erase this. All right, bracket these off in blue. Oh, left my, gotta get that 0x there, yep. So let me bracket these 2 off in blue, okay? So I still have to eliminate y here, okay? So I get, what do I get? Is this the same equation I started with? I think it is. So if I multiply by positive, wait, one sec. What did I just do? Yeah, so, sorry, I just, what I just did here was, sorry about that. Tons of room to make, it's just an absurd number of chances to make mistakes. When I erased all this, I changed this plus sign to a minus. That's going to throw me off. There's just so much room to make mistakes here, guys. Be careful. So I have 0x plus y plus 2z equals, let me erase these. All right. All right, I get 0x. So I get 0x plus 2y plus 4z equals negative 28 here. All right, so let me add these two equations together. I get 3x, these cancel, plus 4z equals negative 29, negative 29. Okay, so I'm going to have 3x plus 4z equals negative 29, okay? So let me use these, right? I've got two equations, two unknowns, so I can solve this. Okay, I'm going to multiply the top by negative 3, the bottom by 2. That'll give me negative 6x plus positive 6x. That'll cancel out, okay? So let's do that real quick, okay? So multiply the top by negative 3 on both sides, right? Whatever I do to one side, I have to do to the other. Multiply the bottom by positive 2 on both sides, okay? I'm going to get, for the top equation, I'm going to get negative 6x plus 21z equals, what's 29 times negative 3? What's that? Negative 87. It's going to be negative 87. The bottom, I'm going to get positive 6x plus 8z equals, what's negative 29 times 2? That's negative 58. Add these two together. I get 29z equals negative 87 plus negative 58. Gives me negative 145. All right, divide both sides by 29. I get z equals negative 5. Awesome sauce. Okay, sweet. So there's my z. Okay, let me just plug this back into one of these. So let's do the red equation here. That'll give me my y. So if I do 2 times negative 5 minus 7z equals 29. Negative 10 minus 7z equals 29. Add 10 to both sides. Negative 7z equals 39. Okay. So let me make sure I did this right. 2 times negative 5. Yep, I did this wrong. Okay, see the mistake I made? So I took my z and I plugged it in for x, right? Big mistake there. I need to plug in negative 5 for 7. Sorry about that, guys. Making a ton of mistakes today. That's my fault. All right, so I'm going to have 2x minus 7 times negative 5 equals negative 29. Or that's a positive 29. Okay, so we have 2x plus 35 equals 29. Subtract 35 from both sides. 2x equals negative 6. Divide by 2, divide by 2. X equals negative 3. Okay. There we go. X equals negative 3. Okay, then I can just take these, my z and my x, plug it into one of these equations over here. That'll give me an equation for y. So let's just use the top one here. So I have 2 times x, that's my negative 3. So 2 times negative 3 plus 2y minus 3 times negative 5 equals 1. I have negative 6 plus 2y plus 15 equals 1. Or 9 plus 2y equals 1. Subtract 9 from both sides. get 2y equals negative 8. Divide by 2, divide by 2. I get y equals negative 4. Okay. Y, let me write that y a little better. Y equals negative 4. Okay, so those are my three variables that I've solved for. Now I'm done. Okay, good job. Number 6, we got 5-word problem. Let's just do a couple of these word problems. I don't want to make, let me see the time on these videos. I don't want to make this too long. So we got a 20-minute, a 9-minute, and then, okay, I'm just going to do a few of these. I don't want to make this video too long for you guys, okay? So theater sells 3 types of tickets: general admission, senior citizen, and child. Mark got 9 gen admissions, 2 seniors, and 3 child tickets. He paid $170. All right. Okay, so here's what's going on here, okay? So they gave us 3 types of tickets. That tips you off, okay? Your 3 variables are the different types of tickets. So let's do X equal general admission tickets. What's that? Y equals senior citizen tickets. And let's let Z equal child tickets we bought. So here's what's going on here. Mark bought 9 general admissions. He bought 9 general admissions, okay? So 9 times general admissions, 9x. In addition to that, he bought 2 senior citizen tickets, so plus 2 times Y. And then he also bought, in addition to that, he bought 3 times Z child tickets, okay? And that he paid $170. So that's going to equal $170, okay? So the total cost of Mark's tickets is $170. Sarah bought 5x, so she bought 5 general admission tickets, 4 senior citizen tickets, and 7 child tickets, and that says she paid $173. Kyle got 4 general admissions, and he got 1 senior citizen ticket, and he got 6 child tickets, and he paid $116.50, okay? They wanted us to find the cost of each type of ticket, okay? So we just got to solve this for X, Y, and Z, okay? I'm going to use Y since I've got a 1Y here. I just have to multiply this by -4 to cancel with the middle equation, or I multiply by -2 to cancel with the top, okay? So let me do that here real quick. Okay. So we've got our system here, okay? So I'm going to go ahead. Let's get rid of, let's deal with these first 2. I'm going to eliminate Y, okay? So I'll multiply both sides of this by -2 here. All right, -2. Okay, that'll give me a -4 here, which will cancel with this +4. So we'll multiply both sides by -2. That gives us -18x minus 4y minus 6z equals 170 times -2, which I believe is -340. Okay, and I'm just going to copy this second equation. Okay, so 5x plus 4y plus 7z equals 173. All right, so I'm going to add these together. I get -13x, those cancel, plus z equals, what's -340 times 170, plus 173? -340 plus 173, that equals -167. Okay, so we got -13x plus z equals -167. Okay, so we got that. Now let's deal with these other 2 equations. All right, so we have to eliminate y, okay? We have to eliminate y since that's what we did in the first step. So I'm going to multiply both sides here by -4. That'll give me a -4y, which will cancel when I add it to my +4y there. Okay. And then I multiply the other side by -4. All right. So I get -16x. And then
Okay, how about Jello?
minus 4y.
Okay.
Lemon fruit ice.
Okay.
The ginger ale.
-16x minus 4y.
Anything else?
Plus minus 24z Okay.
Sugar broth.
And then that equals 11650 times negative 4. So 11650 times negative 4. That equals negative 466. And then I'm just going to copy this middle equation right here. I'm just going to copy this over here. So that gives me 5x plus 4y plus 7z equals 173. So we get negative 11x minus 17z equals negative 466 plus 173. That's negative 293. Okay. Let's move this out of the way a little bit. Okay. I'm just going to copy this up here. So I get negative 11x minus 17z equals negative 293. Okay. All right. So then now we have a system of two equations with two unknowns here. Right, two equations, two unknowns. Okay. So I'm going to multiply, I'm going to use elimination here to get rid of z. So I'm going to multiply both sides of this top equation by 17. Negative 221x plus 17z equals negative 167 times 17. That's negative 2,839. Okay. I can add these two together. I get, what is that? Negative 11 plus negative 221. Oh, sorry. Negative 11 plus negative 221. That gives me negative 232 x. These cancel equals, what's negative 293 plus negative 2,839. That equals negative 3,132. Move this out of the way. Okay. So divide by negative 232 on both sides. Get x equals 1350. 1350, okay? So there's my first variable. I can plug this back in up here to this red equation, solve for z, so that'll give me negative 13 times 1350 plus z equals negative 167, so that original red equation there. Okay. So 1350 times negative 13 equals negative 175.5 plus z equals negative 167. Alright, so that gives me negative 167 plus 175.5. That gives me z equals 8.50. So z equals 850. Alright, and then we can plug both these two into our equation here. Let's just use this bottom one since that has the smallest numbers. We can use that to solve for y. So we get 4 times x, what's that, 1350, plus y plus 6 times my z, which is 850. That equals 11650, okay? All right, let me, gosh, I need a lot of space for this. This is frustrating. So 4 times 1350, that equals 54. So I have 54. I'm just going to do this down here, guys. 54 plus y plus 6 times 850, that's 51, equals 11650, okay? All right, combine my like terms. 54 plus 51, that's 105 plus y equals 11650. Then subtract 105 on both sides. Get y equals 11650 minus 105, so y equals 1150, okay? There we go. right. So we have z, so now we have our three variables solved for. We just got to put them in the context of the problem, okay? So what was my x? My x was general admission tickets. So x is, or it's going to be the cost of a general admission ticket, okay? So x equals $13.50, so general admission, that costs $13. Remember my dollar signs, guys. $13.50. Okay, y was $11.50. That's my senior citizen ticket. So senior citizen, I'll just say senior tickets. Those cost $11.50. And then z, my child tickets. My child tickets, that was $8.50. So child tickets cost $8.50. There we go. So that's my final answer, okay? So screenshot if you need to, pause, rewind. Okay, I'll do one more, guys. Sorry about this, guys. It was harder to record in the hospital than I thought it'd be, so. All right, so number 7, Jamie has a collection of 78 nickels, dimes, and quarters worth $12.40. Okay, number of quarters is doubled. The value becomes $22.50. How many of each type of coin does Jamie have? All right. So he has 78 nickels, okay? So a nickel's worth how many dollars? It's worth $0.05. So he has 78 times 0.05. All right. Oh, wait. You know what I think that is? I'm sorry. What this is saying is he has 78 coins total. He has 78 coins total. Right, so let's let my x be the number of nickels he has. They want us to find how many of each type of coin he has. So they want us to solve for 3 variables: the number of nickels he has, the number of dimes he has, and the number of quarters he has. All right. So then, right, he has 78 coins total. So x plus y plus z, that's going to be 78. Okay? And it's worth $12.40. So that means if you do $0.05 times the number of nickels he has, plus 0.1 times the number of dimes he has, plus 0.25 times the number of quarters he has, that equals $12.40. So that's our second equation here. Woof. Okay. And then the number of quarters is doubled. The value becomes $22.50. So if you do, we're going to double the number of quarters. So that's going to be 0.05x plus 0.1y plus 0.25 and then times 2z. Since he has twice the number of quarters now, that's going to be, and that's equal to $22.15. That's how that one's working, okay? All right, so let's think about which 2 equations we want to use here. All right, so this becomes, let me simplify this right here, 0.25 times 2, that's 0.5. So let me rewrite that as 0.5z. And actually, that makes it so here's my system. That makes it so that my z is the easiest variable to eliminate, because I can take this middle one, multiply by -2, cancels with the bottom, or I can take this term, multiply by -4, cancels with the top, okay? So let me do the top first. Okay, I get x plus y plus z equals 78. And then let me multiply both sides of this equation by -4. That'll give me negative 0.2x minus 0.4y, right? Minus z equals, what's 1240 times -4? That's negative 4960. Okay. All right, so then if we add these 2 equations together, I get 0.8x plus 0.6y. These cancel. That equals, what's 78 minus 4960? What is that? 78 minus 4960 is 2840. Okay, so there's my red equation. Good, good, good. Okay, now let me get rid of some of this. All right, now let's use, since I just used the top two equations, I've got to use the bottom. I got to use this third one now, and I still have to eliminate z. So let me do that. So I'll use the bottom two, and then so I'm going to multiply this by -2, since that's going to give me negative 0.5z, which will cancel with this right here. Okay, so let me multiply both sides of this top equation by -2. Okay, that'll give us negative 0.1x minus 0.2y minus 0.5z. It's 1240 times -2. What is that? Negative 24.8. Okay, let's copy this third equation down here. Okay, that'll give me 0.05x plus 0.1y plus 0.5z. That equals what? 2215. So I just have to add all this together. Okay. All right, negative 0.1 plus 0.05 is going to be, negative 0.05x plus, that'll be minus 0.1y. Those cancel. That equals negative 24.8 plus 2215 equals negative 2.65. Okay, so I have negative 0.05x minus 0.1y equals negative 2.65. There we go. All right, so I have this system of two equations here. I can solve this. I can solve this for x and y, okay? I think the easiest thing to do here, that's probably going to be to multiply this by 6. That'll give me a positive 0.6y. I can add it to this. That'll cancel, okay? All right. No, you're fine. All right, so then we're going to multiply both sides of this by 6. All right, so we get 0.8. Let me just copy that that top equation down real quick. So it'll give me, what is that, negative 0.3x minus 0.6y equals, okay, negative 2.65 times 6 gives me negative 1590. Add them together, we get 0.5x equals, what's 2840 minus 1590. Okay, guys, tons of room to make mistakes, so check your work, okay? And then, oh my gosh, I almost made it. Let me just move this down a little bit. All right, let's divide both sides by 0.5. X equals 25. X equals 25. So he's got, what was my X again? It was nickels, so he has 25 nickels. So let's copy that over there. Okay, then I can plug my 25 in to this, let's do this red equation right here. All right, so plug in X, plug in 25 for X, we get 0.8 times 25 plus 0.6y equals 2840. Okay, 0.8 times 25, that's 20, plus 0.6y equals 2840. Subtract 20 from both sides, 0.6y equals 840. Divide both sides by 0.6. Get 14. 14. So he's got, what was y? Number of dimes. He's got 14 dimes. All right, and then we can just use this x plus y plus z. The total number of coins he has is 78. So his 25 nickels plus his 14 dimes plus the number of quarters he has equals 78. Okay, that's 39 equals 39 plus z equals 78. Subtract 39 from both sides. Get 78 minus 39. That equals 39. So he's got 39 quarters. Right, so this is my final answer here, okay? All right, good job, guys. That's my... All right, so I feel like this has gone on pretty long, so let's save these last three. Let's maybe use these to study for the next test, okay? So the test will be like October 10th or 11th, depending on which period you're in. So let's just save these three to help you guys study for the test, okay? I don't want this video to be too long. Thanks for being with me, guys. Sorry for all the mistakes. And I had to do this in like 5 takes, too, just because people kept walking into the room, so no worries, okay? You guys take care. Thanks for being with me. Hope you're doing well. Ask Mr. Miller for help if you need it. Bye.